Hi, hello. What I'm going to do is I'm going to teach you a method which you can use with either the annihilator method or the guess and check slash undetermined superposition method in the text. And it's a complex method that you can use when you have a homogeneous differential equation and then you add a sine or a cosine or some combination thereof as the driving functions. So let's get started with that. And I am taking an example from a well-known textbook right here. But suppose, for example, we have, we'll say y double prime plus 2y prime minus 3y equals 5 sine 3t. Now, if we were going to do this, we would first have to check that um, this was not part of the homogeneous solution. You can tell that it's not because there is a damping term here, but let's go ahead and just do this anyway. So let's just look at the homogeneous part to find the homogeneous solution. This has the complement, the auxiliary equation or the characteristic equation. We have that. And given that, this factors as r plus, let's see here, I don't want to choke here. So r plus 1, r minus 3, and I better change that. Had a little brain damage here. So you have 3 r's and you have a positive 3 r's. And let's check that. Minus r plus 3 r's, 2r. Minus 3 is 3. So the complementary solution is of the form a e to the x, well, t here, sorry. Let's make that look like a t. That was pretty bad there. A e to the t plus b e to the minus 3t, because the solutions r is 1, r is negative 3. And this is certainly not part of the complementary solution. So to get the particular solution, now we would generally have to assume we had some combination of sine of 3t and cosine of 3t, but why not try to look in the complex domain? And when we do this, why don't we allow y to be complex? And we're going to use the variable z here to indicate that we have a complex type of thing. And for our z here, remember z we will say is going to be x plus iy, x of t plus yt. And this splits up nicely because this is nice and linear. Now this thing right here, let's use Euler's formula, and let's write this as 5e to the I 3t. Now the reason we can do that is e to the I 3t is cosine 3t plus I sine 3t. So what we're going to do is we're going to solve this and then take the complex part. Complex part being the stuff that has an I here. So we're going to take the complex part of this solution here. Now the reason I figure we want to go ahead and do that is that differentiation of this is easy. So if we let z equals e to the I 3t, z prime, piece of cake, and z double prime is 3i times 3i, that's like negative 9. And I should actually multiply this by a complex constant, so I'll call it a. So now when I dump this into the differential equation, I go out 9a e to the I 3t plus 2 times 3, that's going to be 6ai minus 3a. And that must be 5. Okay. Now remember, a is going to be complex. So let's gather some terms here. Let's first of all cancel these for right now. So then I have 6. Well, let's just do this. I have minus 12 times a plus 6i equal times a is equal to 5. So now solve for a. A is 5 divided by minus 12 plus 6i. I want to make sure I got my constants right. All right, that's correct. Now let's do ourselves a favor. Let's divide out by 6. So I have a 5 over 6 here. And then on the bottom, I have a minus 2 plus I. Now, having this at the bottom makes it harder to write in x plus yi form. So what you typically do is you multiply by the conjugate. And the conjugate is going to be minus 2 minus I. So let's do that. And let's see what we get down here. So what I do is I have a 5, 6. Up top, I have a minus 2 plus I. At the bottom, minus 2 times minus 2. That's a positive 4. Minus 2i. Let's see here. So it's minus 2i plus 2i. Those cancel. And then I times minus I. Well, so if you take I times minus I, you get a minus I squared. And we get a 1. And then we get 1/6 up here. And that's correct, I plus 2. Or 2 plus I. And that's going to be your A. So our solution, therefore, is going to be, in other words, our YP solution is going to be minus 1/6, 2 plus I, e to the 3it. Because remember, this is our A. But remember, we want the complex part. So if we take minus 1/6, 2 plus I, this part right here is going to be a cosine of 3t plus I sine of 3t. And remember, again, we want the complex part. We get minus 1/6. Now right here, we have a 2 times cosine of 3t. And then I times I, it's negative 1, minus sine 3t. And we're just going to do this. Then we have our I. And then of this I right here, we have cosine of 3t. And then we have plus 2 sine of 3t. So there's that times a 2. So the solution we want is we want the complex part. So the complex part is minus 1/6 cosine of 3t plus 2 sine of 3t. Okay? Now here's a bonus. If we look at the real part, we take a look at this minus 1/6, 2 cosine 3t minus sine of 3t. This solves, free of charge, this differential equation right here. And I think this solves the following. This solves y double prime plus 2y prime minus 3y equals 5 cosine 3t. So we actually got a freebie. We got a solution to a differential equation we weren't asked to solve. And that's one of the values of using the complex method, is that the differentiation and the plugging in is easy. You do have to get comfortable with complex arithmetic, though. Wanted to make sure that's a minus 1/6 cosine 3t plus 2 sine 3t. Yep. So, and you do get this bonus solution. So, it's so thanks for watching this, and we'll see you later.